The question is, state the output of each of the following logic circuits for the inputs that are given. The first gate here is quite obviously a NOT gate. They've told us that by putting the words NOT in the middle of it. Sometimes they're not always that nice. Sometimes they don't bother putting what the actual name of the gate is. We need to be very, very sure we know what each gate looks like. So, the input for this NOT gate is 0. What's the rule for the NOT gate? What is the rule, Holy? What's always the opposite? Good. So the rule with the NOT gate is this. Whatever the input is, the output is always the opposite. So if the input is 0, what's the opposite of 0? 1. So our answer here is going to be 1. Now while we're on this, I just want to now create a truth table for the NOT gate. So the truth table again is there to show all the possible inputs and output for a logic gate. So you can choose to do this with me if you wish, but I'm going to do this. I'm going to create a table in the top right hand corner, and then I'll have a column for A and a column for B. And what the A and B are representing is input A and output B, like so. Now with the NOT gate, what are the only possible inputs? That's it. 1 and 0. So what is the output for when the input is 1? 0. And what is the output B for when input A is 0? 1. And that's it. That is what we call the NOT truth table. There we are. So again, it's just getting comfortable with creating these tables. That is the only possible inputs and outputs for a NOT. Let's move on to the next one then. Now we're looking at our AND gate. We've got an input of 0 and an input of 1. So we've got now 2 inputs, but of always one output. We'll always only ever produce a single output. What's the rule with the AND gate, Robert? Correct. For the output to be true, both inputs must be true. And I said this with you about the password and your username. The only way you can gain access to your account is if your username and password are correct. You're not going to get access to your account if only one is true. So the only time our AND gate is going to be true is when both are ones, both are true, both inputs that is. So input, let's just call this input A, is currently 0, and input B is currently 1. That would mean output C is, Michael? 0? Kai? I'm asking you what? What is output C? If input A is 0 and input B is 1, what would output C be? Why? Can you tell me why though? Perfect, that's it. The sooner we can be able to explain our answering, the easier this becomes, folks. Brilliant, that's your answer, 0. Now, I want to do the same. I want to create the truth table now for the AND gate. So I'm just going to do it over here. But this time we've got 2 inputs. So I need a column for, just going to make a bit of space here, make sure I'm still in the frame. I want A, I want B, then I also want a column for my outputs. Okay, so what are all of our possible inputs then? Well, we can have 0 and 0. We can have a 1 and a 0. A 0 and a 1. And a 1 and a 1. Those are all of our possible inputs. What about our possible outputs then? 0 and 0, what would C be? 0. 1 and 0. 0 and 1, 1 and 1. 1, perfect. And that is the completed and truth table. Perfect. There we have it. The rule is the only time the output is true is when both inputs are true. That's your AND gate rule. Moving on to question 2 then. Complete the truth table below for the OR gate. Now, the OR gate is the one I hate the most because I can't draw the OR gate. I really struggle to draw it, but we will have a go anyway. So over here, the truth table, of course, we've been given this, but I just want us to, I hate this thing, there we go. I'm going to go for like a rocket ship sort of effect here, but even if it looks really bad, you can always just put in the name of the gate inside. We know that the OR gate always accepts 2 inputs as well, so let's label them up as A and B, and then output of C. So there is our OR gate. That is what we are focusing on. Who can tell me the rule for the OR gate? Who has a rule for me? Suckmeat, tell me the rule for the OR gate. Superb. Only one input needs to be true for the output to be true. Perfect. So, first of all, let's fill in all of our possible inputs. So, just like we did in our AND truth table here, we just do the same. 0 and 0. We can have 1, 0. We can have a 0 and a 1. And then finally a 1 and a 1. Those are all of our possible inputs for our OR truth table. So let's now complete the table and get on to our outputs. 0 and 0 would be a 0, correct. 1 and 0, 0 and 1, 1 and 1. And there we have it. Good. The reason our outputs here are 1 is because we only need one input to be true, resulting in our output being true. And there we have it. So what we've done there, folks, as a whole, is we've covered the 3 gates. We know exactly what they look like. And we've also done the truth table for each one of those gates.